Brad Williams, Frugal Finance. Let's talk about plain vanilla swaps. The name kind of speaks for itself. Just plain vanilla. There's nothing fancy about this particular introductory swap, or let me explain a little bit about plain vanilla swaps. In this section, we analyze the two basic kinds of swaps that are available. The basic swap is known as a plain vanilla swap, which can be an interest rate swap or a foreign currency swap. We begin by considering the mechanics of these plain vanilla swaps. Later in this session, we'll consider more complicated swaps called flavored swaps. Interest rate swaps. In a plain vanilla interest rate swap, one counterparty agrees to pay a sequence of fixed rate interest payments to receive a sequence of floating rate interest payments. This counterparty is said to have the pay fixed side of the deal. The opposing counterparty agrees to receive a sequence of fixed rate interest payments and to pay a sequence of floating rate payments. So you pay fixed, receive floating, pay floating, receive fixed. So this is the short position, this is the long position. Think through the logic there. Why would you do this? The swap agreement notes a timeline when the periodic interest payments will be made. This is the tenor of the swap. The amount of the periodic interest payment is a fraction of a dollar amount specified in the swap agreement, which is called the notional principal. Notional principal is a nominal quantity used as a scale factor to determine the size of the interest payments in the swap agreement. Later, we explore the motivation that these counterparties might have for taking their respective positions. First, we need to really understand the transaction. To see the workings of a plain vanilla interest rate swap, we use an example. We assume that the swap covers a 5-year period, 5-year tenure, and involves annual payment of $1 million notional principal amount. Let's assume that party A is the pay fixed counterparty and agrees to pay fixed rate of 9% to party B. In return, party B, the received fixed counterparty, agrees to pay a floating rate of SOFR to party A. So that would be the long position. The other person is receiving fixed floating who is short. As we have seen, SOFR is the secured overnight financing rate and represents the rate at which the Federal Reserve lends. SOFR-based loans are essentially negotiated business loans that may have a variety of maturities. Most of the maturities range from 1 month to a year. Quotations of SOFR rates appear daily, either within the Fed or just online. Wall Street Journal. Floating rates in the swap markets are most often set as equaling SOFR, which is called SOFR flat. In our example swap agreement, Party A pays 9% of $1 million or $90,000 each year. Party B makes a payment to Party A in return, but the actual amount of the payment depends on movement of SOFR. The SOFR maturity for this plain vanilla swap will be the 1-year SOFR rate, because there is 1 year between each of the payments on the swap. We assume that the 1-year SOFR stands at 8.75% at the time the swap agreement is negotiated. A rate may differ substantially from the fixed rate on the swap. In theory, both parties also exchange the principal amount of $1 million. However, actually making the transaction of sending each other $1 million would not make practical sense. As a consequence, principal amounts are generally not exchanged. Instead, the notional principal is used to determine the amount of the interest payments. Because principal is not actually exchanged, it is only a notional principal, an amount used as a base for computations, but not an amount that's actually transferred from one party to another. In our example, the notional principal is $1 million, and knowing that amount lets us compute the actual dollar amount of the cash flows that the two parties make to each other each year. Generally, the determination of SOFR occurs at one settlement date, with payment occurring at the next settlement date. The payment is said to be determined in advance and paid in arrears. Table 20.2 shows that what is known about the cash flows on the swap agreement at t is equal to 0, the time t which the swap is negotiated. As mentioned above, SOFR at the time of negotiation is 8.75%, but the future course of SOFR is unknown. In each period, the fixed rate payment will be 90 grand. In general, the floating rate payment at a given time t depends on the level of SOFR at period t minus 1. Thus, at the inception of the swap agreement, SOFR is observed, and this determines the floating rate payment that occurs in the first period. In our example, with SOFR 8.75%, when the swap is negotiated, the first floating rate payment will be 87.5. The second payment, which occurs at t is equal to 2, depends on SOFR at t equals 1. And this is unknown when the swap is negotiated. The table shows that SOFR at the end of the swap tenure as NA. This rate is non-applicable because it does not determine any of the cash flows associated with the swap. The convention of determining the floating rate payment in advance and actually making the payment in arrears matches the convention that prevail in the market for floating rate notes and bank loans. So here we have this information. Floating rate obligation is going to be 90 grand per year. Figure 20.1 parallels table 20.2 and shows the cash flows on the swap from the perspective of each party. In this timeline, an up arrow indicates a cash inflow, while a down arrow indicates a cash outflow. The upper panel on figure 21 pertains to party A, the pay fixed counterparty. In each year, party A will pay a fixed amount of $90,000. In return, party A receives a payment that depends on SOFR. At year one, party will receive 87.5 because SOFR stands at 8.75% when the swap is negotiated, because those payments depend on the unknown future of SOFR. The lower panel shows the swap from the perspective of party B, the received fixed counterparty. Each year, party B will receive a fixed payment of 90 grand and make a payment based on SOFR. From figure, it is clear that party A and B have mirror image cash flows. The receipt for one are their payments for the other. This emphasizes the fact that a swap is a zero-sum game. One party gains while the other loses. In general, we can show everything about a swap by just looking at it from the perspective of the single party. As I stated, a lot of this information is old, and this image represents the SOFR, but there's going to be a few where it's going to say LIBOR. That kind of gives you a timeline as to when I first put this together. And I'm too lazy to go in and edit the image. If you see LIBOR, just substitute it with SOFR. Continuing with our example of a plain vanilla interest rate swap, let us assume that SOFR is 10% at time equals 1. The rate will determine the floating rate payment to occur at t is equal to 2, assuming that the swap is paid in arrears. This means that party A will be obligated to pay $90,000 to party B, while party B will owe 100 grand to party A. Offsetting the two mutual obligations, party B owes 10 grand to party A. Generally, only the net payment, the difference between the two obligations, takes place in the interest rate swaps. Again, this practice avoids unnecessary payments. For this example swap, the payments are annual and the tenure is 5 years. Consequently, the swap has 5 determination dates. The dates at which the amount of payments are due from each party are determined. There are also 5 payment dates, the actual dates on which each payment is made. Determination dates occur at year 0, 1, 2, 3, and 4. The corresponding payment dates occur 1 year later than their respective determination dates. In general, the payment dates occur 1 period after the determination date. For example, on a swap with quarterly payments, the payment date follows its corresponding determination date by 1 quarter. While most swaps are determined in advance and paid in arrears, some swap agreements specify payments in advance. These swaps are called in advance swaps. For a swap with payments in advance, the payment due is the present value of the in arrears obligation discounted at SOFR. This is the market-wide convention for in advance swaps. If our sample plain vanilla swap had been an in advance swap the first payment would occur at t is equal to 0. The fixed rate payment would be the present value of 90,000, while the floating rate payment would be the present value of 87.5, each discounted at SOFR at 8.75%. Thus, the floating rate payment would be 80,459.77, and the fixed payment would be 82,758 with some change. Since only net payments are made, the actual payment would be the fixed rate to the floating rate payer. So we have from party A to party B, 82,758 minus 80 is equal to 2295. 90 divided by 1.0875 is equal to 82759 right here. And we're just discounting this at 8 3/4. Same thing here. You're going to subtract the 2, which is the 2298. For the same plain vanilla interest rate swap, which we now interpret as an in advance swap, let's assume that the time is equal to t equals 1 and that the 1 year SOFR now stands at 10%. For this in advance swap, the payment at t is equal to 1 would be as follows. The floating rate payer must pay the present value of its obligation, 100 grand, discounted at the prevailing SOFR rate at 10%. This equals 90,900. The fixed rate payment is the present value of 90 grand divided by 1.10 equals 81 change. This means that the floating rate payer, party B, will make a net payment of 9,901 to payment A. Got that? Let's review these numbers here. Brad Williams, Frugal Finance. See you soon.